Today we're going to be talking about other angles having to deal with circles. We're going to be talking about angles inside of circles, and we're going to be talking about when angles are formed by tangents and secants. So our first equation, and there's a lot of equations, and I often find that students struggle with memorizing all of the formulas. So our first equation is when we have two chords that intersect. So the measure of an angle formed by two chords that intersect in the interior of a circle is equal to half the sum of the measures of the intercepted arcs. So when I have two chords that intersect, angle 1 is going to be half the sum of the measures of the intercepted arcs. So what that means, the measure of angle 1 is going to be 1/2 the sum. Make sure you realize it's addition. This is the only one of our theorems that's addition. DC plus AB. So 1, because 1 intercepts DC, and 1 is congruent to this angle over here, plus AB. Now for angle 2, that's half the sum of BC plus AD. And if we were to use this in proofs, let's call this the two chords angle theorem. Now, there's going to be three different theorems we're going to talk about here. Secant tangent angle theorem. So if you have a secant, here's a secant that intersects a tangent, angle 1 is going to be 1/2. Notice how all of our theorems are going to have 1/2. The difference, that's why I want to highlight, subtracting of BC, the outer one, minus the inner one. Then we're going to have two tangents. When I have two tangents that intersect, the measure of angle 2 is 1/2 the big one, PQR, minus, again, all of them, all of our equations when we're going to have angles outside of our circle are going to be minus PR. And notice how you're always subtracting the bigger minus the smaller. It doesn't make sense to subtract the smaller minus the bigger because then you're going to have a negative number. And our last one is if you have two secants. Now if you have two secants, angle 3 here is going to be 1/2 xy, the outer one. Again, let me highlight minus the angle inside, the arc inside, which is WZ. So again, I can only say this so many times. When your angles are outside, it's 1/2 minus the two arcs. When your angle's inside, by two chords, it's 1/2 plus. Okay, solve for x. Now you have to think, what do we have here? We have two chords. It's in the inside, so it's going to be plus. So x is 1/2 their sum, 150 plus 136. That ends up being 143. Again, secant, or when we had two chords, we were inside, so we added. Now here, I have a tangent and a secant. So 58, that angle, is equal to 1/2 the subtraction now. The subtraction of x, the bigger one, minus the smaller one, which is 64. Now all we have to do is solve. I think I like to multiply both sides by 2. That's going to be 116 is equal to x minus 64. Add 64 to both sides. We get x to be 180. Now I have two tangents. Two tangents intersecting. The angle that's outside, x, is 1/2. Since our angle's outside, it's subtracting 68 minus 24. And x ends up being 7 degrees. There are your lesson questions for the day. 4 questions where you're finding x.